In the field of particle physics, the topic that scientists are most concerned with is the study of dark matter. Because in the entire universe, the matter we can see and touch, such as stars, planets, and objects, actually accounts for only about 5%. Yet for the remaining 95% of invisible matter, humanity knows almost nothing. In other words, if you think you understand the universe, sorry to say you're not even close to 5%. So here's the question. How did scientists discover something that is invisible and intangible? Did they just imagine it out of thin air? In 1933, an astrophysicist named Zwicky stared at a cluster of galaxies for a long time and noticed something strange. According to calculations, these galaxies were moving too fast, so fast that the gravitational force they generated was simply not enough to hold them together. In theory, these galaxies should have already flown apart, but oddly enough, they remained steadily in place. Zwicky boldly speculated that within the galaxy cluster, there must be some kind of invisible matter with a mass hundreds of times greater than visible matter. Unfortunately, this startling conclusion was largely ignored by the academic community at the time. 40 years later, another scientist, Vera Rubin, took up the mystery. She studied the rotation speed of the Andromeda galaxy and observed the same strange phenomenon. The stars at the edge of the galaxy were rotating too fast. To give an analogy, if the galaxy were a sand-made spinning top, gravity would be the glue holding the sand together. But in this case, there clearly wasn't enough glue, yet the top kept spinning steadily without falling apart. What did this mean? It meant that there must be a vast amount of invisible substance within the galaxy, providing extra gravitational pull in the dark. Scientists gave this mysterious substance a name, dark matter. Just how mysterious is dark matter? Let me tell you, at this very moment, every second, billions of dark matter particles are passing through your body, but you feel absolutely nothing. That's because they hardly interact with ordinary matter at all. They don't emit light, reflect light, or absorb light. They pass through everything like ghosts. Since dark matter is so elusive, how can scientists be sure it really exists? The answer lies in gravitational lensing. According to Einstein's theory, massive objects warp the space-time around them. When light passes through regions where dark matter gathers, it bends. By observing this bending of light through instruments like the Hubble Space Telescope, scientists can map out the distribution of dark matter in the universe. The results are astonishing. Dark matter makes up about 27% of the universe's total mass, while the ordinary matter we are familiar with accounts for less than 5%. The remaining 68% is something even more mysterious: dark energy. In other words, the entire visible universe we pride ourselves on understanding is merely a supporting character in the cosmos. Knowing that dark matter exists is one thing, actually capturing it is another. To search for dark matter particles, scientists have moved their laboratories more than 800 meters underground. Why go underground? Because cosmic rays are abundant on the surface and would interfere with detection. Deep underground, these interferences are greatly reduced. But even so, the probability of finding dark matter remains terrifyingly low. To give an analogy, it's like searching for a specific grain of sand in the Sahara Desert, and that grain of sand can pass right through walls. Aside from underground labs, scientists have also turned their eyes to space. In 2015, China launched a dark matter detection satellite named Wukong, the Monkey King. Why this name? Because scientists hoped it could, like the legendary Monkey King, use its golden eyes to detect the monster that is dark matter. Wukong was designed to last only 3 years, but to this day, it has been operating in space for nearly a decade, collecting data on over 150 billion high-energy particles. More importantly, it detected an anomalous signal at the energy level of 1.4 tera-electron-volts, a sharp spike and drop in the number of high-energy electrons. What does this signal mean? It could be the trace left behind by the annihilation of dark matter particles. If this discovery is confirmed, it will be the first direct detection of evidence for dark matter in human history, an achievement comparable in significance to the discovery of gravitational waves. Beyond space-based detection, Europe's Large Hadron Collider is also attempting to search for dark matter in another way. By creating it directly in the laboratory, scientists collide particles at nearly the speed of light, hoping to produce dark matter particles in these collisions. But unfortunately, no definitive discovery has been made so far. Why is dark matter so important? Because it is not only related to our understanding of the universe, but also to a fundamental question: how did the universe come into being? After the Big Bang, it was the gravitational pull of dark matter that gathered scattered matter together, forming the galaxies, stars, and planets we see today. Without dark matter, there would be no Milky Way, no Sun, no Earth, and no humanity. It can be said that dark matter is the unsung hero behind the structure of the entire universe. In 2025, an academician of the Chinese Academy of Sciences revealed at a technology forum that the successor to Wukong, the Very Large Area Gamma-Ray Space Telescope, is currently under development, with detection capabilities expected to improve by more than 50 times. At the same time, dozens of underground laboratories worldwide and multiple space detectors are operating in sync. This nearly century-long quest is now entering its most critical stage. Perhaps in the near future, humanity will finally unveil the true nature of this mysterious substance that makes up 27% of the universe. When that day comes, our understanding of the cosmos will be completely rewritten, and the scientists who discover dark matter will achieve a historical status comparable to Newton and Einstein. This is the allure of dark matter, and the reason why humanity never ceases to explore.